Good morning all. In this class we will discuss a numerical on moment of inertia. In the previous class we have calculated the moment of inertia of a symmetrical figure, that was a T section. In this class we will demonstrate the idea of calculation of an asymmetrical figure like a L section. Okay, so let's start. Example 2. Say this is the section L, of which you need to find out the moment of inertia. The dimensions are, say this is 100 mm, say 20 mm, this one is 20 mm, and say this one is 80 mm. Okay, this is 100, 20, 80. Okay, now we need to find the moment of inertia about centroidal x-axis. So to find moment of inertia about this body, about the centroidal x-axis, we need to find first what will be the centroid of this body, and the axis which is parallel to our x-axis passing through centroid will be the centroidal x-axis. So let's calculate the centroid first. So we can divide this into two rectangles, rectangle 1 and rectangle 2. This is the margin, okay, imaginary margin. So this is rectangle 1 and this is rectangle 2. So let's do the chart, section, area, centroidal, distance y, then ay. Okay, so let's do that first. Area should be in millimeter square, distance in millimeter, and this one in millimeter. Section 1 and 2, only two sections we have. So for section 1, what is the area? Area is area of this rectangle, that is 100 into 20, 2000. Now this is our x-axis and this is y-axis. Okay, now why we have taken this as x and y? In the previous example we taken y as a symmetrical axis because that figure was symmetrical. Now in this diagram this is not a symmetrical axis because the object itself is not symmetrical. Okay, so it is better you take this along this base or this side. So what is the distance of the centroidal distance? This is the centroid of section 1. So the distance from x is basically our y. So that is y1. Y1 is, how much is this one? So this should be 50. half of this, the centroid will be at the middle of this section. So from this edge you need to calculate, this is 50. So y1 is 50. Y1 is 50 and this 2000, this is basically A1. So how much is A1 Y1? A1 Y1 is 2000 into 50. Now for section 2, this distance is, this much is 20 and total distance is 80. So this distance is, this one, it is 60. So A2, it is 60 into 20. This is 20. So for this rectangle, 60 into 20, that is 1200 millimeters square. And what is Y2? Y2, this is the centroid of this section. So the distance from this X to this section is basically 20 by 2. That is 10 millimeter. But this distance. This is the centroidal x-axis of section 2 and this is the centroidal x-axis of section 1. So you need to calculate this distance, that is 50, and you need to calculate this distance, that is 10. So what will be A2Y2? A2Y2 is 1200 into 10. Clear? Okay, so what will be the centroidal distance? What will be the centroidal distance from X of the whole section? The formulation is A1Y1 plus A2Y2 plus A1 plus A2. So now if you calculate what we are going to get, so 2000 into 50 plus 1200 into 10 is 2000 plus 1200. So calculate this first. If you calculate, so if you calculate, you are going to get 35 millimeters. So the centroidal axis is at a distance 35 from this axis. So say this is 50, so 35 will be somewhere here. So this red one is the centroidal x-axis at a distance 35 millimeter. So we need to calculate what will be the moment of inertia about this axis. X is the centroidal x-axis. So what is the formulation? The formulation is simple as the previous one. So I of the whole section is basically I of 1 and I of 2. And these two are calculated about this axis, x-axis, the red one, red axis. So what will be I1? So I1 is about its own axis, that is the mark in blue, it is BH cube by 12. So BH cube by 12 plus. Why plus? Because I need to calculate, I need to use the parallel axis here. So I need to mark what is the distance between these two axes. Okay. So the moment of inertia of this rectangle about its own axis plus area of the rectangle, that is this one, 2000, into square of the distance between these two axes. Now this axis lies as 50 and this lies as 35. So 50 minus 35 square. So that is your I1 about x. You can write this one also. So that is your I1. Sorry. And what will be I2? I2 is, again, this is your B. Sorry, this is your B and this is your H. So B, that is 60, HQ, that is 20 by 12 plus area of this rectangle. The area of this rectangle is 1200 into square of the distance between these two axes. So this axis lies as 10 and this lies as 35. So the distance is 35 minus 10 square. Okay. So this is the moment of inertia of this section. Now, if we calculate, let's calculate it, and after calculation, I think you are going to get the moment of inertia. So do this calculation, and most probably you are going to find this as around this figure. But do check this one, I haven't checked it. So this is the way you need to calculate the moment of inertia of a L section. Now in this way you can calculate anything. I mean, if the section is say I section, if the section is I section, or the section is like this C section, so you have to take three rectangles, say 1, 2 and 3. In this case also you have to take three rectangles. Okay, so take this wave as one rectangle, and this flanges is called flange. This horizontal members, they are called flange, and the vertical one is called wave. So two flanges, so take two sections there, and for one wave one section. So in this way you can calculate anything. So only you need to make sure that initially you have chosen one axis. So what you need to do first is choose your axis. What is your x and y? Find CG. Find CG. Okay, then repeat this process. Okay, so there will be no more lectures on moment of inertia. In next class we will start calculating the deflection of beams. Thank you.